All right, so we got 5.3, video notes level 3, level 4 here. Taking composite functions next step. Now we're not inputting a value. With composite functions, when you input a value, if you were to find k of h of 3, you plug 3 into h, you get an answer. You take that numeric answer, you plug it into k as the new input, you get an answer out. So when you plug in numbers, you get out numbers. When you plug in variables, you get out variables. So here's what we have. We have two functions here, h and k, and we got to do k of h of x. So in class, when I talk about this, you'll hear me talk about substituting french fries for french fries, right? If I want to plug x into the h function, basically what I'm saying is take all the x's in the h function and replace them with an x. Isn't that so amazing, right? Well, that didn't do anything, right? That's like going to the restaurant and saying, I'm going to have a burger and fries, but instead of the fries, can you give me fries? The waiter is going to look at you like, what are you talking about? So plugging x into h function doesn't do anything. So really what that means is you got to look at this as h of x as a whole. Basically, it's saying take all of h of x as a whole, leave it unchanged, okay? But that whole thing, that is the output, technically. Like, if you really think of the input's x, the output is this. This is the output when you plug x into h. Technically, it's just what it normally would have been. We now need to, in composite functions, need to take this whole thing and plug it into the k function. So we need to find k of all of that. What does that mean? That means I take the k function, which is this function right here, x plus 2, big on purpose, and instead of the x, I plug in the input of x squared minus 3x plus 1, right? I'm plugging all of h of x in for k in the x's that exist in k. So what I'm saying is, instead of this x value here, instead of that, I have to plug in this entire thing, x squared minus 3x plus 1, instead of the x. Still have a plus 2 at the end. I'm just replacing the x with what x is supposed to be, the input. Okay? Combine like terms. Combine like terms is all you got to do here. There's nothing else to do besides combine like terms. Don't forget about the plus 2 over there. You're done. There's no equation, nothing to solve. You're done. That one's actually, in the grand scheme of things, relatively straightforward. The next one, a little more challenging because of algebra. Same idea, though. K of x. K of x is saying take the x, plug it into the k function. Well, wouldn't you know it, that the k function already has x's in it, so really, k of x is already known to you. You already know that k of x is x plus 2. But we need to plug that into the h function like we do in these problems. So I want to know what's h of x plus 2. So I take the h function, and instead of all of the x's in the h function, I replace it with what k of x was, with the x plus 2. So instead of both of these x's, I'm plugging in quantity x plus 2, which will have to be squared, and then minus 3 times quantity x plus 2. Again, those were originally my x's, right? Those were my x's. But I replace the x's with what I'm supposed to replace them with, which is x plus 2. Now, this is a little harder because algebra. Don't just square x and square 2. If you put x squared plus 4, that's horribly wrong. Don't do that. X plus 2 squared means x plus 2 times x plus 2. You're going to have to FOIL this. You would get x squared plus 2x plus 2x plus 4. This is no longer a new problem. Moving forward from this point down, this is now just basic algebra that you should already know. Here you distribute the negative 3, minus 3x. Don't forget to distribute it to the 2 as well. And then don't forget, there's always seems to be something over here that people tend to forget. Don't forget about that plus 1. Okay? Again, combine like terms. There's just an x squared. There's 2x and 2x makes 4. Minus 3 is positive 1x. And there's a plus 4 and a minus 6 and a plus 1. That's negative 2 plus 1 is negative 1. Okay? Again, final answer. Doesn't need to be factored. It's not factorable anyways, but doesn't need to be factored. There's no equation, no solving, nothing at all. Okay? Nothing at all. That's level 3. Okay? A little different because you got to plug variables in, a lot more algebra involved. There are a lot more places to make mistakes algebraically, but the algebraic mistakes you make is old news. That's stuff you should already know how to do. The new stuff is just plugging things into the right spots. All right, level 4 takes that one step further, okay? I want to say, okay, for this one, if f of x equals this, find all values such that f of x equals 6. So f of x is supposed to equal 6. Well, what is f of x really the same thing as? Isn't f of x this thing? So by using substitution technically, I am saying f of x, this is no composite function stuff. This is just a basic one first. This is just literally saying f of x, which is really 2x squared plus x, equals 6. And this is an equation. This is a problem you're going to solve. This is probably a factoring. I told you it's coming back. It always comes back, okay? Just when you thought you hadn't factored for a while, here it is. Minus 6 over. Always want to set it equal to 0. And then this is that guess and check. You try to make these things work. For sure, this is going to be a 2x and an x. And then remember, we want these to make 6, but then the inside-outsides need to make positive 1. So let's say this is a plus 2 and a minus 3. This is negative 3x. This is positive 4x. Those do make a positive 1, so that's good. Just to check it, this makes 2. This makes negative 6. That's all good. I factored it correctly. Not only is it factoring, but it's solving, so you set both parts equal to 0. This is old news, right? As soon as you wrote this equation, this should just be, oh, I've done this before, okay? You add 3 over, you get 2x equals 3, you get x equals 3 halves. Is one answer. You subtract 2, you get x equals negative 2. And just to remind yourself to read the question, it said find all values of x that make this work. We found all the values of x that make that work. So this one was pretty straightforward, just kind of plugging in a function. But the next two examples, you'll see how the composite stuff kind of comes back into play. All right, here we go. So notice there's two equations, there's two functions here, an f of x and an r of x. And then we want to find all the x's that make this work. So that's where I'm going to focus first. F of r of x equals 5. I'm going to forget about the equals 5 for a second. That will come back to. F of r of x says take x, plug it into r. But like we just did in level 3, that is not changing anything. That is basically just saying take all of r of x and plug it into the f function, okay? So what does the f function say? The f function says 2 square root x plus 5, too big of a square root, minus 3, okay? But instead of the x in that function, I have to replace it with r of x. What's r of x? R of x is 3 minus x. So instead of the x, instead of that x, I got to plug in r of x, which is 3 minus x. Then you have plus 5 still. You still have minus 3. This thing right now, I'm not going to simplify it yet. This thing right now is the f of r of x, right? I could simplify it a little bit, but before simplifying, this is technically what that is. But what does it say I'm supposed to do with it? I'm supposed to equal it to 5. Equal it to 5. So that's what I do. I got to equal this thing to 5. All right, so let's write this out. 2 square root, simplify inside a little bit here. 3 and a plus 5 is 8. So I have 8 and then a minus x minus 3 equals 5. Good news for you. This is old as well. This is stuff you should already know. This is where algebra can kind of always keep coming back. Okay, let's make this guy a little smaller. All right, so how do we solve for x? What we do first is we got to move the 3 over. You want to get the square root by itself, but you got to move everything else first. Equals 8. Then you divide by 2. You get the square root of 8 minus x equals 4. How do you get rid of a square root? You take a square of both sides. You square both sides. You get 8 minus x. I'm going to go to here. 8 minus x equals 16. You subtract 8, you subtract 8, you get negative x equals 8. Divide by negative 1, divide by negative 1, you get x equals negative 8. So if x was negative 8, then f of r of negative 8 would equal 5. Right? And you could check it. You really could. like, try it. What would f of r of negative 8 look like? R of negative 8 would be 3 minus negative 8. 3 plus 8 is 11. And then 11 you'd have to plug into here. So what's 11 plus 5? That's 16. 2 times the square root of 16, which is 4, minus 3. This is 8 minus 3, which does, in fact, equal 5. You could check your work if you wanted to. Okay? What's new? What's new? What's new is setting this equation up by taking your r of x and plugging it in for the f function. That's what's new. Okay? All right, one more of those examples here. So same kind of situation here. M of n of x equals 0. So I got to do m of n of x first. Same idea. This is level 3 practice, essentially. I take n of x, right? Don't have to go through the French fry example again. I take the whole thing of n of x, and it's going to go into this function right there. So instead of the x in the m function, I plug in all of whatever n of x was. Don't forget the plus 4. This technically is m of n of x, but it has to equal 0. So I set it equals 0. Distribute, you get 2x squared plus 6x plus 4 equals 0. And our old friend factoring has arrived yet again. Okay? First rule of factoring, it's been a while. First rule of factoring, take out a GCF. It's going to make things a little easier for yourself. This thing ideally will and does factor. This next one's pretty easy. X plus 2, x plus 1. And then you got to set both parts equal to 0. This one you don't have to worry about because it doesn't have a variable on it, right? The 2 you don't have to worry about. But x plus 2 is equals 0. X plus 1 has to equal 0. So x is going to equal negative 2, and it's going to equal negative 1. 2 answers for x, both of which, if you plug them into the n function separately, you would get an answer out that then could be plugged into the m function that would each separately give you a value of 0. So this was a lot of level 3, even though it was level 4. The level 4 is making an equation out of it. The level 3 stuff is, can you do the stuff first of plugging a function in for another function? Okay? Can you do that? If you can do that, then you're good. Okay, then you're good. All right, set up the equation, solve. If you struggle with factoring, struggle with solving, we're gonna have to work on that.